Tesla. We have seen the video of that also. So one more motor we are going to see today. That is the induction motor. Okay. After that, we are going to study the BEV powertrain topologies. So which are the different types of topologies which will be used in the BEVs. So we are going to look at BEVs. So, okay, I guess the PowerPoint is visible. If it is visible.
Yes, sir, visible.
Okay, so permanent magnet motor we have seen, as well as with the variable reluctance, which will be combinations, how which combination which will be used in the three model of Tesla. We have seen this. So the next type of motor is a three-phase induction motor. So already we know the basic working principle of three-phase induction motor. How exactly that it is used in the Tesla also. Earlier, whichever the Tesla cars has been developed earlier, initial stage, in that the three-phase induction motor are used. You can see this is the construction of three-phase induction motor. Okay, so we have a flange bracket, then stator, rotor, ball bearing, then motor case, as well as output shaft. These are the parts of motors. When we talk about mainly three-phase induction motor, so everybody knows that there are two types of rotors which will be used in induction motor. So one is a slip ring type of rotor. So another is a squirrel gauge type of rotor. So we know that why we call it as a squirrel gauge type of motor, why we call it as a slip ring rotor. So mainly we use there are two types of rotor which will be used over here. So this is the working principle of induction motor. So in each and every motor, when we talk, there are two types. One is a stator, another is a rotor. Though there are two parts. So we know that the stator inner portion, whatever the stator is, the inner portion is made up of some of the slots. Okay, there are slots are there. So in the slots, uh, whatever the three-phase winding is there, that has been wounded inside the those slots of a stator. Okay, it may be connected in a star way, or it may be connected in a delta way. The connections of the phase wires inside the motor. It may be a star type or it may be a delta type. Okay, stator core, whatever the stator core we use, this is a core, stator core, which is made up of laminated silicon steel. Okay, laminated silicon steel, which will be used in the stator core. So to protect both the stator and rotor. Okay, the stator frame is used outside. Okay, the stator frame is used outside, so which is made up of what? The cast iron. Okay, so with the help of cast iron we are going to uh, protect this both the inside parts, whatever the stator windings as well as the rotor. Okay, cast iron. So over here rotor is made up of. So this is the rotor which has been indicated with the help of the arrows, which is made up of laminated silicon steel. Okay, so that rotor is made up of laminated silicon steel, which is in the cylindrical shape. Okay, the shape of the rotor is a cylindrical. Okay, on the rotor outer surface. Okay, so these whatever the these are arranged. So these are arranged in a parallel, which are arranged in a parallel on the rotor. The slots. Okay, the slots are there on the rotor also, which are arranged in a parallel way. Okay, where the conductor bars, are placed inside this rotor. Okay, so which is made up of copper or aluminum, which is made up of copper or aluminum, and the end rings are provided. Okay, these are connected with the help of end rings to uh, so why these are not connected in parallel, whatever the end rings are there. So in the rotor and caps also we call it as, so those are not not connected in parallel. So because of that reasons, what happens, we are going to reduce the noise of the motor. Okay, we are going to reduce the noise of motor. So how exactly three phase induction motors? So this is A is called as a first phase, B is called as a second phase, or C is called as a first phase. Whatever the pole is there, the opposite pole is act as a the first phase, and this is the second phase, and this is the third phase. So three phase AC supply. Okay, so this is a neutral, and three phase AC supply is connected to the windings, whatever the windings are there on the stator. Okay, stator windings. So inner platform of a stator rotating, which generates whenever we pass a current inside. Okay, each phase acts activate individually. So A phase acts first, then B phase acts, and C phase acts. So whenever we pass the current, so rotating magnetic field will be generated, and rotating with the synchronous speed. Okay, what it rotates with the synchronous speed, the rotor will be rotated at a synchronous speed. So how we are going to write down the synchronous speed? So synchronous speed can be written as, so it is indicated with the help of ns. Okay, ns, we can indicate ns with a, so that is 120 f divided by p. So p, whatever the number of poles we are going to use, that indicates a p, and f is a frequency. So over here, whatever the rotating magnetic field will be generated inside the motor, so we'll cut the rotor conductor bar. So how it will cut the rotor conductor bar, and it will induce the EMF. Okay, EMF inside the rotor, and which will helps the rotor to rotate. Okay, with the help of rotating magnetic field. Okay, which will be generated inside the rotor. Okay, after that the rotor experiences a force, and rotor will rotate in according to the rotating magnetic field. Means the north and south poles are generated on the stator, and simultaneously north and south poles are generated on the stator also. With the help of that, opposite poles are attract each other, and same poles are repels each other. That's the principle, attraction and repulsion principle. Also we know that the Fleming's left hand thumb rule, or we know the Faraday's law of electromagnetic inductions. Okay, so whenever we keep current carrying conductor in magnetic field, so it experiences a force. So according to those laws, this motor also will work over here. Okay, so as space comparison, so it is a very bigger in size. Because of that reason, earlier in the earlier days, we used to prefer in the electric motor, sorry, electric vehicle. Nowadays nobody will prefer, so basically used to prefer the brushless DC motor because of the space constraint, because of weight to power ratio. Also we are going to prefer the brushless DC motor and other types of motor. As I shown in the last lecture, I have shown you a video. So that video indicates that 3S motor. Okay, 3S uh, motor of Tesla. So this is all about the three-phase induction motor. Okay, so synchronous motor is similar to that also, but only it runs at a synchronous speed. So when we talk about BEV's power train topologies or HEV's powertrain topologies, I might have been remembered that already we have discussed a bit of this thing in the previous chapter. Okay, uh, so that is the BEV powertrain topologies. So when we see mainly many possible electrical vehicle topologies are there. So depend on the application, depend on the power requirement, and more analysis is doing in the powertrain topologies. Okay, so uh, electric vehicle topologies are there. Different types are there over here. I have listed over here. First one is the single. So we will see one by one. Okay, single motor, single axle topology. Second is a double motor, double axle topology. Third one is a in-wheel motor single axle topology. So means front axle or rear axle, whatever you wanted to consider, you can consider for the front axle or you can consider as a rear axle. Double means both front axle as well as a rear axle. Okay, so single electric machines, there are two possible technologies for single machine vehicle. Are one is a traditional powertrain formed by adopting the conventional ICE layout. So we are going to take a traditional powertrain of ICE layout, and then that can be converted later on. Okay. So whenever we are considering the traditional electric vehicle obtained from converting an ICE vehicle, इलेक्ट्रिकल व्हीकल को जनरेट कर सकते हैं हम लोग कन्वेंशनल व्हीकल लेके. जस्ट what you need to do, so earliest BUs were converted by using from ICE vehicles. Okay, so in the ICE vehicles what we have a fuel tank. Okay, and where it is replaced with the electric machine and battery pack. So fuel tank, whatever the fuel tank available or engine available, that can be replaced with the help of with the what the electric machine and battery pack. So we not required the engine and the fuel tank. That's why the earlier whatever the conventional vehicle or gasoline engine vehicle can be considered, and that can be converted into an electric vehicle. So traditional electrical vehicle can be obtained from the uh, gasoline engine vehicles. Okay, so some of the components are there in the uh, traditional vehicle or the gasoline vehicle, such as the gearbox, or we can call it as transmissions, or gearbox can be manual or automatic, so that some of the functions are there in the normal vehicle. Okay, so that is gasoline vehicle, there are not necessary to use in the electric vehicle. For example, the use of clutch. Okay, for example, what the use of clutch between motor and transmission, so you can use or you can leave. Or one more thing is you can use the differential. So as we have designed the electrical vehicle in the some MATLAB and Simulink, so there we directly connected to our rear wheels directly. We have connected a single gear. Okay, so if you wanted to use an differential, you can use in between the differential also. Okay, so by using a differential, it is having some of the advantages also. Okay, so when the use of complex multi-speed gearbox for machining, the torque speed characteristics of the power plant and speed and torque required for the vehicle is can be estimated. Okay, so when I am talking about the clutch, it is entirely unnecessary. Where in the electric vehicle? Okay, and the torque speed characteristic of a motor are very different when we compare with a normal engine. So in the first chapter we have studied the characteristic of torque speed characteristic with the help of graph, how the speed varies when the torque increases or decreases when the vehicle speed varies. In the case of gasoline engine as well as in the case of electrical vehicle also, we have seen. Okay, and so with these all these topologies, one more thing I wanted to tell you that, so the differential, still the need of differential is there. Why the need of differential? To balance what the traction force and the speed between left traction wheel and the right traction wheel. So if the electrical vehicle are in use in nowadays also, the differential, some of the electrical vehicles may not be used the differential, but it is very important to use because it controls the traction force of right wheel as well as the left wheel. So when traveling or along the curved path, so जब भी हम लोग curved path में travel करते रहते, तो in that case the differential is comes into picture. मतलब differential क्या करता है? Avoids the slip of the tire. So slip of the tire. So whenever we are moving in a curved path, what happens? Outer wheel is more will move larger than the inner wheel. So in that case, what happens if the differential is not there? Okay, so that what happens? It will not balance both the wheels. That's why nowadays also it's very important to use and differential. So it's not necessary to use the differential in electrical machine. A specialized design combining the single electric machine with the final drive gearbox. Okay, so when we are talking about the electric with the different topologies, so just bit of introduction I have given regarding the single electric machine. So now a single motor with a single axle, or we can call it as a single electric machine with a final drive. Okay, so you have seen this, I guess, in the previous lectures also. Over here, you can see this is the single electric machine with the final drive. Over here, the motor is connected to the differential gearbox, okay, and which is connected to the battery. Simple, it is simple. Electric motors have a torque characteristics, torque speed characteristics close to the ideal performance, whatever the performance of the vehicle traction power plant, and are able to provide near the maximum power at a wide range of speeds. So in that case, so we are going to use this type of single electric machine with a final drive. Okay, there is a maximum torque at lower speed. Okay, when we use an electric motor. Okay, because of the motor flux is initially constant. So motor flux constant के वजह से क्या होता है, lower speed पे maximum torque we can get. Okay, when the machine reaches at a base speed, whatever the electric machine is there or motor which reaches the base speed, क्या होता है, flux will be weak हो जाता है, flux weak हो जाता है, इसके वजह से voltage constant रह जाता है. Okay, क्या होता है, which results in the motor torque decreases. Okay, decrease होता है as the speed increases. So because of the flux weakens, and because of the flux stronger in the initial at lower speed. Because of that reason, what happens at a higher speed, what happens, the torque decreases as the speed increases. Okay, whatever the overall the power is there, that will be remained constant. With an electric machine, so complex whatever the complex multi-speed the transmission is not necessary. Okay, which results in complexity of what clutch and gearbox can be eliminated. What, so these complex things can be eliminated in the electric vehicle. Okay, so typically a small sized high speed low torque motor together with a single speed high reduction transmission can be used. This single electric machines can be used over here. Okay. So what it helpful? It helpful in reduction the mass and inertia. So not necessary to consider the inertia in electric machine. Okay, electric vehicle. So it can be neglected in the electric machines. So it can be integrated in the single component. So it reduces the mass of the vehicle. So that is differential gearbox can be can it can be same. It can be used in a single component, both the things. So this type of V, whatever I have shown over here, so this type of battery electric vehicle is a very predominant use in the market nowadays. Okay, so because central driver motor with fixed ratio still which encounters and mechanical loss as well as variable gearbox, there is no possibility of operating motor in maximum efficiency. So simple layout of electric vehicle is the single electric machines can be used over here, and with the help of gearbox and differential can be used. So you can eliminate the differential also. You can use only the gearbox with a battery. So there are pair of battery can be used whenever we use the two motors. Okay, two motors if we use, we can use a pair of battery. So for one battery we are going to use one motor, so for another battery we are going to another motor. So pair of motor also can be used the electric machine.
Sir, the slides are not changing, sir.
1 minute के क्या प्रॉब्लम हो रहा
सर
है?
स्लाइड नहीं चेंज हो रहे.
1 minute, हाँ. I'll stop the presentation and one more. फिगर में ऐसा कुछ नहीं है, ज्यादा एक ही फिगर है खाली. Now it is visible.
Yes, sir. Now it is visible.
Okay, this figure indicates the single electric machine with a final drive. This is a final drive. Single motor is used. That's why we call it as a single electric machines. Okay. So यहाँ पे हम लोग gearbox यूज कर सकते हैं, डिफरेंशियल को एलिमिनेट कर सकते हैं. तो हम लोग अननेसेसरी कंपोनेंट इलेक्ट्रिकल व्हीकल में यूज नहीं करेंगे. उसकी वजह से अपने को स्पेस भी पड़ता है इलेक्ट्रिक व्हीकल में. तो डिजाइनर क्या कर सकता है, अपने खुद के इससे कैसे भी डिजाइन कर सकता है. हाउ मतलब अगर आप कन्वेंशनल व्हीकल और गैसोलीन व्हीकल को भी आप इलेक्ट्रिक में कन्वर्ट करना चाहेंगे तो यू कैन यूज द स्पेस ऑफ फ्यूल टैंक, यू कैन यूज द स्पेस ऑफ engine. So in that place you can anyhow how you wanted to design your car, you can design. This is the first topology of electric vehicle machine. Okay, the second topology is the double electric machine with a double axle drive. So you can see in the figure, you can identify that double electric machine means we are using a motor over here and we are using a motor over here. So with a double axle drive, what are the double axle drive? This axle is having also having a power, and this also is having a power. It simple indicates that. So it double electric machine with a double drive. So relatively simple, because electric machine can be controlled with a good precision. Okay, if you wanted to achieve a good speed, you can use this type of topology. Okay, so it is possible to use more than one machine in any of the vehicle. Okay, and for example, separate motor can be used as here, that can be shown over here. You can see one battery used over here, so one more battery I can use for this uh, so axle drive. This axle drive I can use separate battery, and for this axle drive I can use a separate battery. If a single battery pack is there, whole vehicle is having a single battery pack, in that case I use only a single battery pack. Okay, so the research, whatever research is going on currently, so on this type of double electric machine with a double axle drive, the more and more research is going in this type. So all the prototypes are building in this type of. Okay, so we know that the conventional electric vehicle has a single electric machines. Okay, so this topology has been sufficiently developed for what? So they already this topology is there. So this topology has been developed 5 years back. Okay, so which has been built in the year 2015. 2015 5 साल पहले ही ये जो भी डबल इलेक्ट्रिक मशीन विद डबल ड्राइव है, so that can be developed in the Tesla model. So उसका कुछ पैरामीटर, कुछ specifications. So it has been introduced in the 2015, as I said. Over here the separate front and rear motors are used. Separate front as well as rear motors are used with a single gearbox ratio. So for the front there is a different gearbox ratio, and for the rear so there is a different gearbox ratio. So also we can call it as a, this is as conventional engine 4-wheel drive. Okay, so acceleration performance, it is having good acceleration performance. So for example, the Model X is capable of, so this is an developed for Model X, it is capable of accelerating a speed at around from 0 km to 100 km per hour in less than 5 seconds. You can imagine that in less than 5 seconds it is achieving the speed of the 100 km per hour. So when we compare with the normal vehicle, it is twice the performance, as quick as twice the performance of normal gasoline engine. Okay, so this electrical uh, vehicle topology still requires a use of pair of differential. So one for the front and one for the rear. Okay, as I said, you can use the differential or you can leave the differential. Okay, so but if you use the differential, what happens? It adds the mass to the vehicle over here. So whenever we use two traction sources, whenever we combine in a single vehicle, so that it is used to control the strategy of a designer. Okay, control the strategy of designer. So he can manage over here the more degrees of freedom over here, because it is in more flexibility to investigate an effective and efficient operation method, or because more space is available, because we don't have any engine, we don't have any fuel tank over here. So he can imagine and he can design with the help of more degrees of freedom. Okay, so this is the second type of topology, that is a double electric machine with a double axle drive. Simple figure tells you that how it looks, the double electric machine and double wheel drive. So this is the second type of topology we have seen. The third type of topology is a multiple electric machine with the independently driven wheels. So independently named figure itself indicates that the motor will be used over here and the motor will be used over here. So when we use this type of configuration, or when this type of topology, so it is possible to eliminate the use of differential by using separate. For this wheel, I am using a separate traction motor to drive the wheel. For the right or left, I am going to use a separate traction motor, so that I can say that the vehicle is independent on the left wheel and the vehicle is independently on the right wheel. Okay. So when we talk about speed and torque of the left wheel and the speed and torque of the right wheel, can be equalized electronically. So ECU we can call it as, so electronic control unit. So with the help of that electronic control unit, we can equalize the speed of left wheel and the speed of right wheel. Okay, so कितने speed पे भाग रहा है left hand side wheel और कितने speed पे भाग रहा है. So torque, speed and torque can be uh, evaluated with the help of some electronic control unit, so ECU. Okay, over here, it improves the efficiency and reducing the vehicle mass. How? Uh, because individual wheels having a individual motor, which will increase the efficiency. How we are going to reduce the mass? Some of the components we have eliminated over here. So that's why the vehicle will be reduced the mass. Okay. Over here, you can see we don't have any gearbox also. Without the gearbox, gearing, low speed high torque motors are necessary. Okay, so the speed of the motor, if it is slow, the torque will should be very higher. So but in the case of fixed gearing, belt drives or planetary gearbox can be connected, so that between the motor and the wheels, to provide a better commercial, better speed for this electric vehicle. Okay, so over here we are not using any differential also. So make the differential makes more space available, so which may be useful for additional battery capacity, as for we can use for the longer average or longer range, we can call it as. So also because of electric motor at an individual wheel, so this wheel and this wheel, we can use the electronic controller, so that the motor can be controlled on a individual space. Okay. So energy management is also very important over here, because of the operating cycle. So left wheel operating cycle is different, right wheel operating cycle. So because of these things, so energy manage, we have to manage the energy for the left side motor, or we have to manage the energy for right hand motor also. Okay, so the torque balance, we have to do the torque balance between left wheel as well as the right wheel, must be controlled with the help of electronic differential. So which may require a complex or non-linear control, and design is very difficult whenever we use a differential to control the torque between the left as well as right hand side. So it is very important, so that the design will be further difficult to do when we use an differential to control the torque. Okay, so cost. So whenever we talk about this topology, uh, so bit of मोटर इतना तो ज्यादा कॉस्ट नहीं रहेगा, तो बैटरी थोड़ा सा ज्यादा कॉस्ट रहेगा. ओके, सो इलेक्ट्रॉनिकली ग्रेटर कॉस्ट ओवर हियर whenever we talk about, and the power equivalent powered motor and associated with the hardware, adding to overall cost of the system. So battery it will add a motor. So whenever we use an differential and electronic differential controller also, if you use, so those all those components will be will add the cost of a vehicle. So this is the multiple electric machines with the independent driven wheels. So name itself says the both wheels are independently rotating with the help of two different motors. Okay, last one topology is in-wheel motor drive. So as we have seen this topology, so only two motors we are using in the front wheel. Okay, if you see this topology, okay, you can see over here we are using four motor at a four wheels. So that's why we call it as a inline motor wheel. Okay, so this is also connected to the control unit, so that this all the motors can be controlled with the help of this control unit, and the battery single battery pack can be used to control the these four types of motors, different types of motors. Okay, so this can be add a more cost to the vehicle. So because individual motor which will be used at the uh, individual wheels. Okay, so when we talk about energy efficiency, over here in wheel motor is integrated into vehicle wheel. It is eliminates all the mechanical gears, whatever the gearing system, differentials, each and every things over here which will be eliminated. So in-wheel motor can be used with the transmission also, without transmission also, depends on the type of applications over here. So efficiency is increased by 20% when we use this type of in-wheel motor drive. So efficiency drastically बढ़ जाता है यहाँ पे. Okay. For the passenger car application, some of the disadvantage in terms of vehicle performance also, as the vehicle independent driven on integrated motors are there. That is a disadvantage when we use this type of motor. In-wheel motor requires electronic differential controls. So that is an disadvantage to advantage in to follow the curved path. Okay, but it is disadvantage. So it will be increase the cost. Okay, so torque, speed control. Okay, of both front wheel as well as rear wheel. Okay, so which are integrated in the wheels, so that motor increases the wheel mass as well as the inertia of the wheel. Okay, तो यहाँ पे एक disadvantage भी है कि wheel mass भी increase होता है क्योंकि मोटर inline motor है, and inertia भी बढ़ेगा of the tire. Okay, adding to the unsprung mass with a negative effects as well as stability of the vehicle and safety and comfort of the vehicle. So there are many other things are there, positive vehicle dynamics as well as some of the things are there, negative vehicle dynamics are there. So some of the positive vehicle aspects of using inline wheel, it has been shown over here. Individual motor are used, that's on positive vehicle dynamics. So direct drive for individual wheel. we can say in another term, it will provide a direct drive. Okay, quick torque response. So that is another the positive vehicle dynamics we can say, and it allows to easy torque measurement of individual wheel. Okay, so that is another positive vehicle dynamics. Okay, it is easier to implement. Okay, so because we are using on an individual wheel, okay, it is easier to implement as compared to whenever we are incorporating into a single component of both the gearbox, ek mein dal rahe differential, ek mein dal rahe. Okay, and good dynamic control, good dynamic control, better dynamic control when we look in terms of vehicle performance. So as well as control features such as anti-lock braking system, we can integrate into this, so that system and dynamic tracking control compared with the conventional ICE vehicles. Okay, this is all about the in-wheel motor drive. Okay, vehicle model and simulation techniques. So there are two types of techniques we are going to use. Vehicle modeling techniques can be classified into two ways. One is a forward-facing model. The second is a backward-facing model. So दो type simulation कर सकते हैं. एक कर सकते हैं हम लोग forward facing model, as well as this indicates the forward facing model, and one more figure is that this indicates the backward facing model. So forward facing simulations are present in approach to vehicle transmission. They use a driver model to control the vehicle speed, okay, and which is similar to the human driver only. So this figure indicates the illustrate the what the forward facing simulations. So यहाँ पे कौन से स्पीड हम लोग कंपेयर करते हैं, ये फॉरवर्ड व्हीकल्स डायनामिक फॉरवर्ड व्हीकल सिमुलेशंस में तीन स्पीड रहता है, दो स्पीड रहता है. पहले तो हम लोग कंसिडर करते हैं कि ड्राइवर मॉडल कंसिडर करते हैं, और सेकेंड वाला क्या कंसिडर करते हैं हम लोग, रेफरेंस स्पीड कंसिडर करते हैं, एंड देन एक्चुअल स्पीड कंसिडर करते हैं. सो एक्चुअल स्पीड आर देन कंपेयर्ड, अब बाद में कंपेयर किया जाता है तीनों स्पीड को और दोनों स्पीड को. सो ड्राइवर मॉडल, दैट मीन्स वी आर कंसिडरिंग ओवर हियर द longitudinal driver. Okay, so lateral dynamics are ignored over here, and longitudinal dynamics of the vehicle has been modeled over here, as I shown whenever we modeled electric vehicle. So in that one slot is there for the reference speed. ओके, सो रेफरेंस स्पीड मतलब वो जो भी रेफरेंस स्पीड है व्हीकल का, तो वो एक्चुअल स्पीड के साथ कंपेयर किया जाता है. ओके, फॉरवर्ड फेसिंग सिमुलेशन में. ओके, तो वहां पे जो भी एरर जनरेट होता है, तो that error, whatever the error is giving an error signal, that is used to generate a control signal to control the torque used to power the vehicle. Okay, so with the help of comparing both the wheel speed, so actual speed and reference speed, so whatever the error which will be generated, with the help of error, with that error, the control signal which is generated, that control signal is used to power the vehicle. Over here, driver models normally use which models we are going to use over here, driver models? The PI controller. So I'll show you. So whenever we model a vehicle, so last part is remaining, as we know that the last part is remaining our electrical vehicle modeling. So that is the longitudinal driver. So in that I'm going to show you that, so where the reference speed is available and what is your actual speed. Okay, so in that, if you double click on that, the longitudinal driver, over there it has been indicated with a PI controller. Basically we are going to use the PI controller over here. Okay, so that is the forward in the forward facing simulation. Okay, so the source of power of BEV is an electric motor, we know that. Okay, and appropriate model is used to you some of the appropriate models we are going to use, that is the driver model. In that we having a torque as well as mechanical braking signal. So this torque from the motor is passed through the model of transmission and then applied to the driving wheels. Okay, so as I said over here, the longitudinal model has been taken into consideration, and lateral dynamics are ignored in the case of forward facing simulations. So whatever we have designed an electrical vehicle, that is we have designed for the forward vehicle simulation. Okay, forward vehicle simulation. So some of the advantages of forward vehicle simulations is that it is because higher amount of efficiency. So this method is used for designing the vehicle hardware. So physical system can be used to model hardware, and detailed control development also can be done. So we have designed a physical model inside the MATLAB and Simulink. That is the useful of this forward facing simulation. Okay. However, this has a uh, simulation are very expensive and time consuming. So समझो whenever you are giving a more number of simulation steps are there, it is very time consuming. So that why some of the components we are not considering. So suppose so PWM, instead of considering PWM, we are considering it as the averaged. So with the help of averaged, the simulation time can be reduced. So that's why we are not taking any complicated battery system. A simple battery system is considered because the simulation time has to be reduced. Also, simulations are very expensive in the case of forward phase simulations. Okay, फॉरवर्ड फेज सिमुलेशंस में सिमुलेशन बहुत ही एक्सपेंसिव है. सो लैटरल डायनामिक्स हम लोग कंसिडर नहीं करते हैं. ओके, सो लैटरल डायनामिक्स सो फिजिकल सिस्टम्स से कंट्रोल सिग्नल को करने के लिए वी आर गोइंग टू चेंज द signals from physical to suppose if I have a physical system, I wanted to change it to the signals to the Simulink, so that physical system to the Simulink converter has to be used to convert the signals. Okay, so required speed, vehicle consumption of power. So this is the whatever the required speed when we have a reference speed and actual speed. So when we compare both things, the vehicle will give you an required speed. So what will be the power will be consumption consumed in the case of forward phase simulations can be estimated with the help of SOC. Okay, SOC estimations can be taken into considerations whenever we are simulating, and the vehicle travel distance in kilometer per hour, so that also can be taken into consideration when the vehicle moves from one place to the another place. So whenever we simulate a forward facing simulations, so our the graph, okay, drive cycle graph should be is almost, it should equal to the standard drive cycle. Okay, standard drive cycle से match करना चाहिए. So that kind of parameters can be provided whenever we are simulating any electric vehicle by using a forward facing simulation. Okay, so one more type of simulation is that is backward facing models. So in the case of backward facing model, this is a backward facing model we have. Okay, so feedback signal which will be go to the comparator over here, and the controller can be used over here to control the vehicle. Okay, so whatever the velocity of the vehicle is there, so that will be measured, and whatever the required amount of speed, समझो कि 50, 40, 60, 70 किलोमीटर पर आवर रिक्वायर्ड स्पीड है, तो वो अचीव करेंगे हम लोग कि एक्चुअल स्पीड कितना है और रिक्वायर्ड स्पीड कितना है. तो वो अचीव करने से करेंगे जब हम लोग बैकवर्ड फेज सिमुलेशन अप्रोच यूज करेंगे. सो दीज आर द सम ऑफ द इनपुट्स एंड आउटपुट्स ऑफ बैकवर्ड फेसिंग सिमुलेशन ऑफ द व्हीकल. Okay, so velocity output will be wheel torque, and the wheel speed, some of the parameters has to be considered over here. So whenever we are calculating the by considering all the environmental losses जो भी हम लोग consider करते हैं, तो some of the rolling resistance coefficient, aerodynamic coefficient, vehicle mass and inertia, road gradients, wheel radius. These are the things we are going to consider in the backward. So backward facing simulation uses the opposite approach. Okay. In forward facing model, the inputs of the components are generalized forces and outputs are generalized motion. Okay, यहाँ पे आप फॉरवर्ड फेसिंग ये पूरा डिटेल्ड है पूरा एंड बैकवर्ड फेसिंग में so these are the for the motor. Okay, so these are input and output for the motor. uh, so once we go with the backward facing, यहाँ पे opposite approach होता है. जब भी हम लोग इन फॉरवर्ड फेसिंग मॉडल, input components can be considered as a generalized forces and output are generalized motion. यहाँ पे उल्टा होता है. यहाँ पे बैकवर्ड फेसिंग मॉडल में क्या होता है, input are the generalized motions. Okay, input are the generalized motions and output are the generalized forces. Okay, generalized motion. This is the difference between when we compare the backward facing model as well as forward facing model. Okay, so we will stop over here. So we will continue with the backward facing simulation tomorrow, as well as we are going to calculate the vehicle body and environmental losses. Okay, whenever we consider a vehicle model. Okay, so by considering the angular velocity, by considering uh, the torque, by considering the full vehicle. So from environmental force, the vehicle can be calculated. Okay, so this we will see, as well as some of the transmissions we will see. So transmission calculations we will see in the tomorrow's lecture. Okay, we will stop over here. So 1 minute. As I'm telling you, so I'm going to show you that I have modeled. So let it be. I'm going to show you in the practical itself. Already I have modeled a full electric vehicle. Whatever I have, last part is remaining. I have modeled that also. I'm going to show you the simulation directly in the practical. Okay, let us stop over here, and we are going to continue in the next lecture. So it is comfortable for you at 1:30, or shall we go with the 8 o'clock morning
Sir, morning is fine, sir.
for everybody? For all?
Yes, sir.
Okay. Okay. So we'll have a lecture in the morning tomorrow. Okay, 8 o'clock.
No, sir. Can you please schedule at 1:30?
Okay. Then some of them are telling at 8 o'clock and some of them are telling at 1:30. So which should be considered.
So 1:30, sir.
Okay, let us think. Okay, evening तक think करेंगे और decide करेंगे. Just put your attendance. We have a test in this week or next week for unit number 1 and 2. Okay, unit number 1 and 2 will have a test this week or next week. So quickly put all of you your attendance.